Hi friends, welcome to Sri Chaitanya. This is Umasankar, All India IT Coordinator. Yeah, after complex numbers, we are handling the most important topic, very important for board examinations and especially for JEE Mains and Advanced. Because complex numbers, after complex numbers, why we are concentrating vector algebra means there are several applications interlinked with the complex numbers and vector algebra. That's why. So you can solve several problems in complex numbers with vector algebra and vector algebra problems with complex numbers, vice versa. So my friends, actually in previous classes, so far we have completed 2 lessons in vector algebra. Already I mentioned nearly 18 to 20 lessons I have prepared on vector algebra. In lesson 1 to 6, from lesson 1 to 6, we have concentrated only on properties of vectors and problems on properties of vectors, because they play a very good role in the entire vector algebra. If you have mastered those properties and preparations and principles and the basic fundamental formulae and notations, then solving the problems becomes very easy for you. So my friends, actually in the first 2 lessons, I have introduced what is the basic terms and terminology in vector algebra, what is a vector and what is called zero vector and what is a unit vector, and what are the direction cosines and direction ratios and fundamental theorem of collinearity and coplanarity and angle between 2 vectors, like that points that we have covered in the first 2 lessons. Now today in properties of vectors, lesson 3, we are concentrating on the problems, very good important problems. Here I am solving very beautiful problems, and please try to understand the essence behind the questions. The same type of questions they may ask even for the competitive examinations, mains and advanced examinations also. The principles you have to master and practice, okay? And please my friends, don't forget to check the description. There I am providing all the links of the previous videos and the previous lessons, and along with that I am providing some of the great assignments and question papers for you, for your benefit. Okay my friends, now through this video, through this lesson number 3, now we are concentrating on what? Simple problems. We are concentrating on what? Problems based on addition and subtraction of vectors. Though it is, it looks like very simple, but the basic essence one should practice on this particular area. Now coming to problem number 1. Read the statement properly. What is given? Forces PA bar, PB bar, PC bar diverge from the point capital P, and other forces AQ bar, BQ bar, CQ bar converge to a point Q. This is the information given for you. Try to understand the language, especially in vector algebra. So whenever we are solving a problem in vector algebra, 2 points are very important. Keen observation of 2 points are very important. Are they given points? Are they giving vectors? So try to understand the difference between these 2. Whenever points are given for you, then you try to convert them into position vectors, and based on the properties of vector addition and subtraction, we may solve the problems in vector algebra. But here what are given? Forces PA bar, PB bar, PC bar diverge from a point. They are all diverge. Diverge means all the vectors are starting from P. That means P as the initial point. See, observe, from all these vectors, P as what? Initial point. So these are called initial vectors, I can say. And AQ bar, BQ bar, CQ bar converge to a point. So these are the vectors diverging from the point P and they are converging to a point Q. Then what they are asking? They want to find the resultant of 6 forces. So here the main concept is resultant of 6 forces. Resultant means sum of all 6 forces. How many forces are there? Here 3 and here again 3. So how to solve? Okay. So these are all of the forces given for me, total 6 forces. So they want resultant of these forces. How to solve? So here apply the basic common sense. As actually in the previous videos, what I mentioned, what is AB bar? This is position vector of B minus position vector of A. This is AB bar, where O is my origin, which is a fixed point. Suppose if my instead of B, instead of O, if I have taken my P as the origin, I can also represent the same thing like PB bar minus PA bar. So, based upon the initial point we can write, we can establish the vector in terms of the position vectors. Okay. Now, my friends, so this is the concept, this is the sum, this is the resultant that we have to find. Here you try to understand the vectors and their orientation. Here PA bar is given, here AQ bar is given. So, you combined both of them. So, PA bar plus AQ bar, you write like this, put them in a bracket, and again here what? PB bar is given and here BQ bar is given. So, again you write PB bar plus BQ bar, and again you write PC bar and CQ bar, PC bar plus CQ bar. So, what happens? This is nothing but PA bar plus PQ bar, AQ bar is nothing but PQ bar, and again PB bar plus BQ bar is again PQ bar, and again PC bar plus CQ bar is again PQ bar. So, how many PQ bars are there? 3 PQ bars are there. So, answer is what? 3 PQ bar. This is what resultant of these 3 forces. Okay. The same thing I have given in the solution part also. Please try to understand, try to practice. So, whenever we are adding 2 vectors, the end point of one vector is initial point of another vector, then we can write the sum like initial point of first vector and end point of the second vector. That means PA plus AQ is PQ bar, PQ bar. Like that we can write the vectors. Similarly, PB plus BQ is PQ. Similarly, PC bar plus CQ bar is PQ. Therefore, total 3 PQ. This is about the first problem, elementary problem. But here, how can we add the 2 given vectors whenever this kind of situation arises? So, when addition is possible, that is the important point. So, in that aspect only this problem is important. Now, coming to the second question. Yeah, this is one of the important model several times even in mains examination, and once upon a time in advanced examination also they asked this kind of questions. And of course, my friends, read the statement properly. In a regular hexagon, what is mentioned? Regular hexagon. Regular means a hexagon. In a hexagon, all the sides are equal. Lengths of all sides are equal. Then only it is called what? A regular hexagon. Okay. So, this is the hexagon. How many sides are there? 1, 2, 3, 4, 5, 6. If a polygon has 6 sides, then that polygon is called hexagon. Since it is regular hexagon, so this length is equal to this length and this length, this length and this length, all are same. So, here try to understand the problem. What is AB bar plus AC bar plus AD bar plus AE bar plus AF bar, that they are asking. Here the important point is for all these vectors, A is the initial point. So, this is my A. So, all the vectors are like this, they are situated like this. This is B and this is C and this is D and this is E and this is F. This is all are coinitial vectors. So, ultimately what they are asking and what they are expecting from us, what is the resultant, like that previous problem it is. So, what I am doing is now, so I have taken all the vectors like this, but in the place of AB bar, because AB bar and CD bar, ED bar, they are what? Parallel, and moreover since it is regular, both are same. That is why AB bar equal to ED bar. So, I have just replaced AB bar with ED bar. Similarly, AF bar, see here AF bar is nothing but CD bar. The same thing here I have mentioned. Just what I did, I have replaced AB bar with ED bar and AF bar with CD bar. The reason is very simple. See, if you have observed these vectors carefully, then what do you understand that here AC bar is there, here CD bar is there. So, by adding these two, it becomes what? AD bar. Similarly, here it is what is called, it is AE bar is there, and here it is ED bar is there. What is AE bar plus ED bar? That it becomes AD bar. Already AD bar is there. See. So, conveniently I kept the corresponding vectors in a bracket, and by addition of vectors AC bar plus CD becomes what? AD, and similarly AE bar plus ED bar is equal to AD, and here it is AD bar already given. So, the resultant becomes what? 3 AD bar, like that. So, several times questions based on this hexagon were repeated in all competitive examination. So, my friends, even in your regular preparation also, please try to concentrate and collect all the problems based on the regular hexagon in vector algebra. Okay. Now, coming to the third problem. Yeah, read the problem carefully. Again, they have asked this question in the competitive examination, and moreover, it is very, very important even for board examination also. And see, read the statement properly. If the sum of two unit vectors is a unit vector, what is given? Sum of two unit vectors. That means, suppose if A bar is a unit vector, that means mod A bar is equal to 1, and B bar is also a unit vector, that means mod B bar is also 1, and this is what the sum of two unit vectors, A bar plus B bar, and this is also 1. This is the information given for you. For example, if I have considered my vectors as A bar, B bar, C bar, then what is the magnitude of their difference? What they are asking? That they are asking what is mod of A bar minus B bar. This is the question mark. So, while writing the problem, immediately if you are preparing the data like this, then a problem is very clear for you. Now, how to solve this? See, so without a loss of generality, what I have taken is, because on paper you have to write like this. These are the proper important steps. Whereas in your regular practice, you can go ahead like this. Here, traditional way I am solving the problem. Actually, in advanced way also we can solve the problem in another model, but I will explain. But now I am solving this problem in a traditional way. What is traditional way? Suppose this is vector AB bar equal to A bar, BC bar, this is another vector. See my friends, these two are not the co-initial vectors, some vectors, and this is sum of two vectors, because here what is given, two vectors are given, whether they are unit vectors or not, that is different, and again sum is also given. So, whenever sum occurs or sum is, we are adding two vectors, then by parallel addition of, law of parallelogram, that addition sum of two vectors is nothing but what, diagonal of the polygon, diagonal of the parallelogram. So, AB bar equal to A bar, BC bar equal to B bar, therefore AC bar equal to, this is sum of two vectors, that is AB bar, AC bar equal to A bar plus B bar. As per statement, what is given? This is unit vector, so modulus is 1, this is unit vector, therefore modulus is 1, and mod of A bar plus B bar is also equal to 1. This is the given statement for you. Now, my question is, what they want? They want mod of A minus B, that is A bar minus B bar, that they are asking. Okay. So, here say for example, this is my A bar, so this is my B bar. So, automatically this is what? This is about A bar plus B bar, because this is my, if it is B bar, see the direction, here it is B bar, then automatically the reverse direction vector, it is minus B bar. So, okay. So, whenever it is B bar, see the direction here, direction is like this. So, in a negative direction, opposite direction, minus B bar comes. So, this is A bar and this is minus B bar. So, it becomes what? A bar minus B bar. So, actually through this diagram, what I am going to establish is how to, what is the addition of two vectors I have mentioned, and again the same thing, what is the difference of two vectors also I have mentioned. Now, here my question is, I need to find the magnitude of this vector, and I need to show what is this mod of A bar minus B bar I want to find. So, what I am doing is, see my friends, here I am just applying some of the properties of triangles concepts also. See my friends, here actually if you have observed this triangle ABC and ACD, actually here AD bar is equal to A bar minus B bar, therefore AD square is equal to mod of A bar minus B bar whole square. Okay. My friends, see here actually in a triangle ABD, ABD, this is what? Angle is 120 degrees. This is angle is 120 degrees. Okay. Why it is angle 120? Because this is an equilateral triangle. ABC is an equilateral triangle. Why? All the sides are equal. So, this side length, and this side all are equal. Since they are equal, this is equilateral. So, this is angle is 60, this angle is 60, this angle is also 60. Since this is 60, therefore, this angle is what? 120 degrees. So, now observe this triangle. Now, forget about the A bar and B bar. Now, consider the magnitudes only. This is what? AB, this is what? BD, and this is what AD. Sides of the triangle only we have to consider. Now, from the triangle ABD, according to the cosine formula, cos 120 degrees is equal to AB square plus BD square minus AD square by 2 into AB into AD. They are not vectors. AB square means modulus, that is number only. So, okay. Now, what is AB square? AB means this is unit vector, mod A bar, that is 1, 1 plus 1 minus AD square by 2 into 1 into 1. After simplification, you will get the answer as AD as what? Root 3. So, the difference of two vectors is nothing but root 3. This is the traditional process, and here how to visualize whenever two vectors are given for you, and what is about addition and what is about subtraction, geometry in vector representation, and like this geometry is very, very useful for you. My friends, we can also solve the same problem in another way. See, actually what they want, mod of A bar minus B bar. This is a little bit advanced procedure. Okay, what I am doing is, mod A bar plus B bar, it is given as what? This is nothing but 1. If I have squared on both sides, again these things you will get in next classes, that is after learning the properties of the dot product, you can solve this problem like this. So, what is mod of A bar plus B bar? This is a little bit advanced one. This is nothing but A square plus B square plus 2 A bar dot B bar, which is equal to 1, and A square is equal to 1 because that is magnitude is 1, it is given, and plus B square is also 1 plus 2 A bar dot B bar is equal to 1. So, ultimately A bar dot B bar, I got this as minus 1 by 2. But what I want only mod of A bar minus B bar. So, what I am doing is mod of A bar minus B bar I need to find. So, what is mod of A bar minus B bar whole square? Just like the mod of A bar plus B bar whole square, it is also A square plus B square minus 2 into A bar dot B bar. So, this is nothing but 1 and this is nothing but 1 minus 2 into what is A bar dot B bar? That is minus 1 by 2. After simplification, this becomes 3. Therefore, mod of A bar minus B bar is equal to root 3. This is another way of solving the problem. Once after getting the knowledge on dot product and properties of dot product only, we can solve. But so far we are in what? Properties of vectors only. With the help of the properties of vectors, how to solve this problem? This is the traditional method. Okay? You have to practice all the ways because sometimes the techniques are very, very useful and they are helpful for solve other problems. Okay, my friends? Now, coming to the next one. This is a very, 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 very important problem and somehow the lengthy problem also. My suggestion would be, you please practice the solution and simultaneously you please practice these results as a formulae also. Because in a competitive examination sometimes they may ask the results as bits in objectives. So, please try to read the question properly and by heart the result, and this is my suggestion. So, read the statement. If O is the circumcenter and P is the orthocenter of triangle ABC, what is given? O is circumcenter and P is orthocenter. You know what is circumcenter? The point of intersection of perpendicular bisectors of the sides of the triangle are concurrent and point of concurrence is called the circumcenter. What is orthocenter? That is point of intersection of altitudes drawn from the vertices to the triangle are always concurrent and point of that concurrence is called the orthocenter. These are the definitions. With this result, we are proving the beautiful information, we are getting the beautiful knowledge especially about the relationship between circumcenter and orthocenter of the triangle. My friends, please do not neglect this question, by heart every aspect in this problem. Now, I am solving the problem in a traditional way. See friends, so this is my triangle ABC and this is the ABC triangle. So, this is one altitude, this is altitude, okay. This is AL is one altitude and this is AM is another altitude, that means they are perpendicular. So, this is my point of intersection of altitudes, nothing but what? Orthocenter, and what is given orthocenter? That is P, okay. And of course, this is these are the perpendicular bisectors of the sides, okay. These are the perpendicular bisector, that means this length is equal to this length and the point of intersection of the perpendicular bisectors is O, and I joined O and P. This is the circumcenter, this is what? Circumcenter, and this is what? Orthocenter. Orthocenter. So, I have joined OP. So, through this lesson, we are finding another beautiful relation. What is OP? Distance between OP. So, here in the given results, OA bar plus OB bar plus OC bar is equal to OP. So, if we want magnitude, then take modulus. Okay. And moreover, here what I am going to solve is, okay. So, from triangle OBC, so this is OBC triangle, you just consider this triangle. Here what happens, let us suppose O is my origin, for example. So, this is OB bar is position vector and OC bar is position vector, and suppose this is my midpoint perpendicular bisector of these sides. So, if I have joined these two lines, this line is always perpendicular to BC, and moreover BM is equal to BC. That means it divides BC, M divides BC in the same ratio. So, by section formula, what is OB bar plus OC bar? Actually, in the first video, I introduced what is the section formula. So, if M divides line segment joining BC in the ratio 1:1 or midpoint indirectly, therefore, OB bar plus OC bar is equal to OD bar. So, what I am doing is, in first result, OA bar plus OB bar plus OC bar, in the place of OB bar plus OC bar, I have replaced with 2 OD bar. You call this as equation number 1. But what I want, OA bar plus OB bar plus OC bar, I need to show this is OP bar. Apply the common sense. Suppose if 2 OD bar is nothing but, listen it very carefully, AP bar, what will happen? Automatically by addition of vectors, OA bar plus AP bar is nothing but OP bar. So, my job is completed. So, now the $1 million question is how to prove 2 OD bar is nothing but AP bar. That is the most important point. That means distance between orthocenter and vertex of the triangle is equal to, is twice the distance between circumcenter and the circumcenter and side of the triangle. That means AP is equal to 2 OM. This I need to find. And moreover, my friends, this is perpendicular to BC, and moreover OM is also perpendicular to BC. These two lines are perpendicular to BC, means these two are what? Parallel. Parallel. And moreover, if I have proved that AP is equal to 2 OM, then or let it be OD. So, say for example, this I am taking D conveniently. So, 2 OD, then this is the then my job is completed. So, this is the only crucial part and important part in this problem. For that, I am applying here the concepts of the properties of triangles and etc. etc. So, see now in quadrilateral P, L, C, M, you just observe this quadrilateral. You just observe this quadrilateral P, L, C, M. Here it is 90 degrees and here it is also 90 degrees. Now, see my friends, here it is 90 degrees and here it is 90 degrees because it is perpendicular, So, if it is C, then this is what? 180 minus C. This is what? 180 minus C. If it is 180 minus C, obviously this angle is nothing but C. What angle? APM is C. And this is 90, automatically this is also 90. So, this is C and this is 90 and this is AP and this is AM. Okay. So, here the same things that I have mentioned. Angle PLC is equal to angle PMC equal to 90 degrees. Angle PLC, this is 90, angle PMC 90 degrees, angle LPM that is 180 minus C. This the same thing I have mentioned. So, angle APM, this is angle C. Clear? Now what I am doing is same thing again I am redrawing the diagram. See very carefully what points are mentioned, what is O and what is P, and what are the perpendicular bisectors and what are the altitudes of the triangle, etc. Now since O is circumcenter, and of course if it is angle A, then here it becomes angle 2A. These are all what basic elementary properties of the triangle, of this triangle. So angle at the circumcenter is twice the angle at the vertex based on the property, and this is BOC, this is 2A, this is A, therefore it is 2A, and moreover this becomes A, and again this becomes A, and here it is 90 degrees, and here it is also 90 degrees, and this side BC, BD, and this is DC, both are equal. So what I am doing is, this is circumradius, say capital R, this is circumradius, say capital R, this is circumradius, say capital R. Now all the weapons are in my hand. Now what I am doing is, from triangle OBD, this triangle you consider, from here, since it is a right angle triangle, you take cos A. What is cos A? OD by OB. That is OD by capital R. So OD is equal to R cos A. So 2OD is equal to 2R cos A. 2OD is equal to 2R cos A. Again from the triangle APM, here you just consider this triangle APM. What I said, this angle is what? 180 minus C. So obviously it is what? C, and it is what? 90 degrees. So from this triangle, my sin C equal to AM by opposite side by hypotenuse AP, AM by AP. So but triangle ABM, what is that? ABM. You just consider this right angle triangle. If you have considered right angle triangle, then cos A is equal to, from this triangle cos A equal to, here cos A is nothing but AM by AB, AM by AB, but that AB is equal to C, because in properties of triangles, in general what we are taking is, in a triangle AB, these are all the standard notation of the triangle. This is small a, and this is small b, and this is small c. Okay? So AM by C, therefore AM is equal to C cos A. So you substitute in the place of AM with C cos A, and what is AP? That is C sin C by cos A. But you know that by sine rule, C by sin C is equal to 2R. So AP is equal to 2R cos A. So here AP is equal to 2R cos A. I got it. This is equation number 4. And from equation 2, 2OD is equal to 2R cos A. I got it. So from 2 and 4, I proved that 2OD is equal to AP. That means distance between orthocenter and vertex of the triangle is equal to distance between twice the distance between circumcenter and the perpendicular distance from circumcenter to opposite side. This is the relation. If you have already known this particular relation, then problem is very simple for you, not necessary to prove all these things. Here why I have proved all the things, because this is very, very important result. So problems based on this information also we can expect in competitive examination. In that aspect only here I have derived. Now problem is very simple for you. So this length is twice of this length, and moreover this AP is perpendicular to side BC as well as OD is also perpendicular to side BC. Therefore AP bar is equal to 2OD bar. So whenever magnitudes are same, magnitudes are equal, and direction is also same, therefore in vector point of view AP bar is equal to 2OD bar it comes. Now my job is very simple. Now I am concentrating my first question. That my first question is what? So these are all the things. So now OA bar plus OB bar plus OC bar is equal to OA bar plus 2OD bar, that already we proved. Now in the place of 2OD bar I have written AP bar. So OA bar plus AP bar is nothing but OP bar. Similarly, second question. Second question is PA bar plus PB bar plus PC bar. Okay. Again here I am writing PA bar plus PC bar as 2PD bar. How come? Again same PA bar plus PB bar is equal to PB bar plus PC bar. PB bar plus PC bar equal to 2 PD bar I have represented. Why? because D is midpoint, D is midpoint of BC, that means BD is equal to DC. Now, instead of O as origin, you just consider P as your origin. Now, PD is nothing but what? PD is nothing but what? Our position vector of the point P, D with respect to P is nothing but what? This is again apply the section formula, that is nothing but what? 2 PD bar. So, and already you have proved PA bar is equal to 2 DO bar. So, 2 DO bar plus 2 PD bar, that is 2 into DO bar plus PD bar. So, you can write that as 2 PD bar plus DO bar, which is nothing but 2 PO bar. So, my friends, this is a very, very important result, and the same result we can also prove with geometry, and with the help of the properties of triangles also we can prove. This is the proof that we are now solving the same problem with help of vectors. That is the importance and beauty of the vectors, and this one can solve with the help of the properties of vectors only. Okay, my friends. Now, again another problem. Read the question carefully, and this is also one of the valid problem. Several times questions were repeated in this model especially. Read the statement. PQR are the points on the sides AB, BC, CA. So, what are PQR? They are the points on the sides AB, BC, CA. So, see, these are the points, and moreover, so P is point on AB and Q is point on BC and R is point on CA, such that AP is to PB, that means P divides AB, Q divides BC, R divides AC in the ratio 1:2. That means AP is to PB, this is 1:2. That means total length is 3, of that AP is 1/3 and PB is 2/3. Similarly, BC, similarly AC, like that the points are situated. The question is, we have to show that PBQR, this is my PBQR, PBQR. This I want to show as a parallelogram. How can I show that PBQR is a parallelogram? Only thing is, I need to show the opposite sides are parallel and they are in equal length. Okay, that is very, very important. Whenever I have shown BQ bar is nothing but PR bar, and BQ is equal to PR. Similarly, BP bar is equal to QR, and moreover BP bar is equal to QR bar, then only it becomes what? A parallelogram. How come? That with help of the vector algebra is the important point. See? So, my friend, this is the information given for you. So, I have considered total AB bar as 3A bar. So, if I have taken this as my 3A bar, so automatically it becomes A bar and it becomes 2A bar. Similarly, if AC bar, if I have taken this as a 3B bar total, as per the concept this is B bar and this becomes what? 2B bar. That is the beauty. That is the way you have to imagine, because the ratio has given it as a 1:2. So, this is the same information that I have given. So, AP bar is equal to A bar and PB bar is equal to 2A bar, that I have mentioned it. Similarly, remaining also. Now, my question is, what is my BC bar? BC bar is, if A as origin if I have considered, I can write as BC bar as a position vector of C minus position vector of B, AC minus AB, because I know what is AC bar and AB bar. So, this is what? 3 into B bar minus A bar. So, total this is what? 3 into B bar minus A bar. Since this is the ratio, Q divides BC in the ratio 1:2, so BQ is B bar minus A bar, magnitude point of view, and it is what? 2 into B bar minus A bar, because that is the given concept. So, the same thing here I have proved, BQ bar equal to B bar minus A bar. Since B bar equal to BQ bar is equal to B bar minus A bar, and PR is PR also what? Already we have proved it. PR is what? Where is that? BR minus BQ bar is, and PR bar is equal to AR bar minus AP bar, B bar minus A bar. So, from 1 and 2, what we observed? These two vectors are equal, and moreover they are parallel, because these 2 points situated on the sides of the triangle at the same distance. So, automatically these two are parallel, and moreover the vectors are equal, therefore they are parallel to each other. Similarly, what I am going to solve is the same thing I am solving another two sides, the same thing. See, so my friends, again PB bar. Already I know this is my A bar, this is my 2A bar, because I have considered AB bar as 3A bar, and this is B bar, and this is what, 2B bar, because my AC bar as 3B bar, and this is what, B bar minus A bar, and this is what, 2 into B bar minus A bar, because already I proved my BC bar as 3 into B bar minus A bar. Okay, my friends. Similarly, now PB bar is equal to 2A bar, RQ bar is equal to, again I can write with respect to A as position vector, AQ bar minus AR bar, and again that AQ bar I can write it as AB bar plus BQ bar. See the diagram, and you know what is AB bar, BQ bar, AR bar. You substitute everything, and ultimately you got PB bar as 2A bar. So PB bar as 2A bar, actually it is not necessary, because from the diagram itself it is very clear. But if you are writing anything on paper, the steps must be like this. That's why here I am giving the clear-cut established solution, because just with the diagram itself one can easily understand and easily solve the problem. That is a different story. Here, whenever, suppose if they ask the same question in board examination, what kind of steps that you need to write on paper is very, very important. That presentation is important. That's why here I have written all the steps very clearly. So again what I proved, PB bar and RQ bar. PB bar and RQ bar both are same vectors, and their magnitudes are same, and they are all parallel. Therefore, these two sides are equal and magnitudes are equal and they are parallel. These two sides are equal and magnitudes are equal and they are parallel. So automatically my figure BQRP becomes what? A parallelogram. So this is the way of applying the properties of vectors while solving or for solving geometrical oriented problems with respect to vector algebra. Okay. Now my friends, if you like this video, please share and subscribe my channel, and please don't forget to press the bell icon, and we will meet with the next problem session soon. Thank you.